This video is an introduction to differential calculus or differentiation. Now, in functional notation, f-x is called the derived function or the derivative of f of x. And the key words and phrases to look out for to know to do this technique are differentiate, find the derivative, calculate the rate of change, calculate the growth rate, find the gradient of the tangent to a curve, and if the question has any of these words or phrases, then we need to differentiate. So, first of all, we're going to look at the derivative of x to the power of n. So the general formula, if f of x equals x to the power of n, then f dash x, the derivative, equals n multiplied by x to the power of n minus 1, where n is a rational number. Please note that before differentiating, we need to express the function in the form x to the power of n, so we need to eliminate fractions or roots. So the first example, we want to find the derivative of the following: f of x equals x to the power of 6. So our f dash x is going to equal, bring down the power, so it's 6 multiplied by x, and we're going to lower the power by 1 to 5. In the next example, we want to find the derivative of f of x equals x to the negative 2. So we're going to write down f dash x, and that's going to equal, bring down the power, so it's negative 2 multiplied by x to the negative 3 by lowering the power by 1. And we can write that as a positive integer by writing negative 2 and moving our x to the negative 3 to the denominator, so it's negative 2 over x cubed. This example, we want to find the derivative of f of x equals x to the power of 5/3. So f dash x is going to equal 5 over 3 multiplied by x, and if we take away 1, we get 2/3. And we can rewrite this using our rules of indices. So f dash x is going to equal 5, and it's the cube root of x squared all over 3. This example, we want to find the derivative of f of x equals x to the negative 1/2. So f dash x is going to equal negative 1/2 multiplied by x to the negative 3 over 2. And then we're going to make that into a positive index by moving it to the denominator. So it'll be negative 1 over 2 x to the power of 3 over 2. And then we're going to use our rules of indices to change that into a root. So f dash x is going to equal negative 1 over 2, and it's the square root of x cubed. In this example, we want to find the derivative of 1 over x. And we need to remember that we need to express it in terms of x to the power of n. So f of x is going to equal x to the power of negative 1, because by moving it to the numerator, we have to make our power of 1 negative. So f dash x is going to equal negative 1 multiplied by x to the negative 2. And then we can make that into a positive index by moving it to the denominator. So f dash x is going to equal negative 1 over x squared. In this one, we have f of x equals the square root of x, and we need to write it as x to the power of n, and the square root of x can be written as x to the power of 1/2. And then f dash x is going to equal 1/2 multiplied by x to the power of negative 1/2. We can then make that into a positive index by moving it to the denominator, so it will equal 1 over 2 x to the power of 1/2, and then we can change that x to the power of 1/2 back into the square root of x, so it will equal 1 over 2 root x. Now when we're asked to differentiate a constant term, so a numerical value, we need to remember that from our rules of indices that x to the power of 0 equals 1. So we can rewrite this as 8x to the power of 0. Then when we differentiate it, f dash x is going to be 0 multiplied by 8, x to the negative 1, and 0 times anything is just going to be 0. So therefore we can say that any constant term that we differentiate is going to have a derivative equal to 0. So f dash x is always going to equal 0.